Welcome back for the second semester's homework help for Henderson, Bailey, and Losi. Now, I know we weren't here yesterday, Monday, January 6th, but some of us gave out Monday's homework for Tuesday, and some of us, all classes are doing something different, so I still have Mondays on here. If you look at Monday's number 4, for those of you who need help on Mondays, the science department surveyed all their 8th grade students to determine what type of animals was their first pet. The results are displayed in the table below. Cats, dogs, rabbits, birds, snakes, so forth. Okay. Based on the survey results, how many of 1,500 students in the entire school would say their first pet would say a bird was their first pet? Well, this is obviously a proportion table, so we need to set up our proportion box. Okay, so I've set this up. Birds needs to be our focus. So based on the information on the chart, there were 32 who liked birds, who had birds as their first pet. So I have 32 birds out of total students here on the chart. I want to go back to the paragraph and see if by any chance they told me. The science department surveyed all the 8th grade students. Okay, nowhere in there does it say our total students, so we have to use the chart. Okay, so we got to add it up. So 56 plus 66. If I add that up there, 6 plus 6 is 12. Carry your 1. So 6 and 6 is another 12. So 122 just for cats and dogs. Okay. This right here, 19 plus 32. If I add the rabbits and the cats, because rabbits and birds, it's still part of it. 9, 10, 11. Carry your 1. So that's 3, 4, 5, 51. Add my 27 to that. So 7, 8, 78 plus 122 for the cats and dogs. So I have 122 plus my 78. So 8, 9, 10. 7, 8, 9, 10. 200. So for the birds of total students, there are 200. Out of 200 students, 32 had birds for their first choice. Now what it's asking me to do is make a prediction if there were 1,500 students. So now I'll put 1,500 here. And I'm looking for my X. So this is a proportion. What I can do is look for easy scale factor, 200 into 1,500. That does not go pretty or easily, but I have 2 zeros, so I can get rid of the zeros. 0 for a 0 and for a 0. So I'm looking at 2 into 15. It still doesn't go nice. However, 2 and 32 can be reduced. 2 goes into 2 one time. 2 goes into 32. What's half of 32 is 16. Okay, now I can see that 1 times 15 is 15. I have a pretty scale factor now. Whatever you do to the bottom, you do to the top. So now I have 16 times 15, and that should give me my answer. So I'm going to do 16 times 15. Please pause the video and try this on your own. And then you can check yourself in a minute. No one knows whether you got it right or not. Just your honesty, your integrity. 5 times 6 is 30. So 5, 6, 7, 8. Scratch, scratch, lay your egg. So anything times 1 is itself. It's 14. And we get an answer of 240 students. Another way you could do this is you could keep doing EFT, keep building it out. 32 and 200. So the next one would be 64 over 400. And continue on with the pattern. Moving on, Tuesdays, for those of you who had to do Tuesdays. Tuesdays problem number 2. Mr. Milbroth has 15 girls and 10 boys in his first period class. He puts each student's name on a popsicle stick and puts the sticks in the container. What is the probability that Mr. Milbroth drawing a girl's name 2 times in a row if he randomly draws a popsicle stick and does not replace it in the container and then randomly draws a second? Okay, so before we begin, let's really think about what we have going on. We have this jar here with some sticks in it with 15 girls and 10 boys in his first period. That's a total of 25 students. He puts each student's name on the popsicle stick and pulls from the container. What's the probability of drawing a girl's name 2 times in a row? So it's not just one action, there's 2 actions. And for every action, we have a fraction. So first of all, we have action number 1. And on action number 1, I want to know what is the probability of drawing a girl's name. And then action number 2, is that something different or something new? Nope, it's the same thing. I want another girl's name. So what's the probability of drawing a girl on the second action? Now the kicker here is he does not replace it in the container. So first of all, what's the probability of drawing a girl? That's 15 out of 25 total. So we have 15 possible outcomes or desired outcomes of the girls out of 25 total outcomes. Now before I even go on, I know this can reduce. These both end in 5, so I can reduce it by 5s. 5 times 3 and 5 times 5. So this fraction reduces down to 3/5. Now for the second action, what we have to assume is that he came up here and he drew one of those 6 out. So we don't have 15 girls anymore. We only have 14 girls. And if we only have 14 girls, we don't have 25 total anymore. We only have 24 total. So the second fraction is not going to be the same because once he took one out, it changed the whole container. So now we only have 14 out of 24. Now looking at these are both even numbers. So that means I can break them down by 2. 2 times 7 is 14. And 2 times 12 is 24. So that reduced down to 7/12. Now I got to take the 2 together. So 3/5 times 7/12. Now looking at these together, guys, we can reduce any top with any bottom. 3 and 5 cannot reduce anymore. 7 and 12 cannot reduce anymore. However, 3 and 12 can. 3 goes into 3 1 time. 3 goes into 12 4 times. And 7 and 5 cannot. So now I have 1 times 7. So 1 times 7 is 7. And 5 times 4. 5 times 4 is 20. Because we did so much reducing in the end, we're done. 7 is a prime number. It can't be broken down anymore, and it cannot go into 20. So my final answer is 7/20. So that should have been answer B. Okay, moving on to Wednesday's homework. Okay, looking at this problem on number 3 on Wednesday. A soft drink company is sponsoring a contest. The chance of purchasing a winning bottle is 1 out of 12. During 1 month, a family purchased 72. About how many of these bottles were not winners? Okay, this is definitely a proportion because we have two things we're talking about. We're talking about winning out of total bottles. So set up a proportion table. So the winning bottles, there's 1 winning bottle out of every 12. Now the family didn't purchase 12, they purchased 72. So how many are winners? Well, 12 goes into 72 6 times. So my scale factor is 6, 12 times 6. If I do it to the bottom, do it where? To the top. Now guys, this had to do with winning bottles. But the key here is detail, detail, detail. And wanted to know how much were not winners. So 6 is definitely not my answer because 6 is definitely how many that actually won. If 6 is too small, 12 is probably too small. Okay, so now I got to take my total of 72. Some of those 72 are going to win, so it can't even be 72. What's my answer without doing any work? 66. But I need to subtract 72 minus the 6 that are winning bottles. Okay, that becomes a 6. That becomes 12. So 12 minus 6 is 6. And my answer here is 66. That was it for your homework this week. Thank you.